So, in the previous lecture of electric and hybrid electric vehicle, we have started with the motor, electric motors used as a traction motor in electric vehicle as well as hybrid electric vehicle. Okay, so we have seen two kinds of motor. One is the DC motor and another one is the induction motor. And we have seen certain strategies how we will be able to control the speed as well as torque speed characteristics of this particular motor. Okay, so what are the power electronic converter that can be used to control to generate the certain amount of torque by this motor that we know now, right? So we have gone through various methods available to control the speed of the DC motor as well as induction motors, which are known as DC motor drives and induction motor drives. Okay, so we have two more motors left to discuss, but before that we are going to discuss some important aspects of this electric vehicle. Whenever we are driving the electric vehicle, we will require one motor. Okay, so now we know that what motor can be used for an electric vehicle. Okay, and we also know what this motor will do. Okay, generally this engine in case of IC engine vehicle and motor in case of electrical vehicle, it will generate certain amount of torque and rotation of certain revolutions per minute. Okay, so basically the function of the motor is to generate the torque and generate the rotation of the wheel, right? And there will be one controller which will control this torque as well as this speed, that means revolutions per minute. Okay, so the question should arise in our mind that whenever we try to move that particular vehicle, an electric vehicle or hybrid electric vehicle, how much power is required to drive that vehicle? Okay, and how much energy is required to carry out the road trip? Okay, so these two are the important questions while we are designing an electric vehicle, whether it is a two-wheeler, three-wheeler or four-wheeler or even a truck or bus. Okay, so each and every design for a particular purpose will require different ratings of motor, because we need to generate certain amount of torque in order to provide the acceleration to the vehicle, right? So starting acceleration, high starting torque will be required whenever our vehicle is at standstill. Okay, so ultimately you must know what is the efficiency which is provided by electric vehicle and how you will be able to compute the various parameters, various performance parameters of electric vehicle. That is what we need to see. Okay, so now we will start with the computation of this torque, power, and we will also try to compute the traction force required. Okay, we already have gone through various equations earlier, right? Whenever we talk about the traction force, then traction force is nothing but the acceleration force required to move the motor as well as the force required to overcome the different resistances. Say one is aerodynamic drag, another one was rolling resistance, and third one was gradient resistance, or we can also call it uphill resistance. Okay, so we know the equations of all these particular parameters, but how to find out this particular torque required, particular force required to move the electric vehicle, right? So we will go through some of the equations and some simple examples such that we will get the clear cut idea how we will be able to find out the different performance parameters and efficiency of electrical motor. Because in case of petrol vehicle, we know that for 1 liter of the petrol, our vehicle will flow 50 to 60 kilometer. If we talk about two-wheeler, if we talk about the four-wheeler, then the range should be 12 kilometer to 22 kilometer. So if we talk about the efficiency of these petrol vehicles, then efficiency is very much low. While in case of this particular vehicle, if we talk about the electrical motor, then we know induction motor will provide the efficiency up to 90%. Right? So whatever cost per kilometer will be there, that cost per kilometer in case of electrical vehicle will be very much less compared to petrol vehicle. And this is the one of the reason why we should go through the electric vehicle. Okay, apart from this pollutions created by the petrol vehicles, this is also one of the added advantage of electric vehicles. Okay, so let us now try to compute all these parameters. Okay? So we know that controller is there. Okay, we are talking about the power electronic controller, and this controller will control torque as well as speed, that is revolutions per minute of an electrical motor. Okay, so talking about this torque, whenever I talk about the vehicle torque, what should be the value? The vehicle torque in Newton meter is given by the force multiplied with radius of the wheel or tire. Okay, so if you know, if you are able to compute the force and if you know the radius of the tire, then we will be able to calculate the amount of torque which can be generated by the electrical motor. Okay, so whatever this vehicle torque required, this vehicle torque should come from, it should come from electrical motor only. Okay, so now we know that is this much amount of torque is required. Okay, so that torque should be generated by this electrical motor. Okay, so this is what we know. Okay, now whenever we talk about the force, okay, this much amount of force will be required to move that vehicle. Okay, and apart from this movement, the force will be required to overcome rolling resistance, aerodynamic resistance, gradient resistance, and also it needs to provide the acceleration for the vehicle. Okay, so talking about this torque, it is to overcome rolling resistance, aerodynamic resistance, gradient resistance, and also it will provide acceleration. Okay, or you can say pickup for vehicle. Okay, so this torque will get the vehicle speed. Okay, so what is the speed that we get, right? So generally when we talk about the vehicle speed, that vehicle speed is measured in terms of kilometer per hour. Okay, and it is defined by motor revolutions per minute. Okay, this vehicle speed is defined by motor revolutions per minute. Right, so whenever we talk about the measurement of torque, at that time whatever speed available to you in kilometer per hour, that speed needs to be converted into meter per second. Okay, so generally speed is defined in kilometer per hour, so we need to convert this speed in meter per second, right? So you must know how this conversion will take place. Okay, so generally we know whenever I want to convert my kilometer per hour, into meter per second, then I need it to be multiplied by 1000 meter, and 1 hour contains 3600 seconds. Okay, so ultimately, whenever your speed in kilometer per hour is divided by a factor of 3.6, you will get your speed in meter per second. Okay, this is my one way, right? Or you need to convert this speed into rpm. Okay, so generally whenever we want to convert this rpm into meter per second, at that time you need to multiply this rpm by radius of tire in meters, and this needs to be multiplied by 2 pi by 60. Okay, so it will be equal to rpm into radius of tire divided by a factor 9.55. So if you know the value of rpm, if you know the radius of tire, then we will be able to calculate speed in meter per second. And if there is a speed given to you in kilometer per hour, then also we will be able to convert our speed in meter per second. Okay, this is what we are getting. So we know the speed now. Speed means we know the velocity in meter per second. And if you know the velocity, if you know the force, then we will be able to calculate the power required in the watts. Okay, so my next performance parameter would be power, and generally power is calculated in watts. So it is nothing but the force in Newton multiplied by velocity in meter per second. Okay, so we know the force. What is force? Force is equal to vehicle torque divided by resistance of tire, right? So force is nothing but torque divided by radius of tire into velocity in meter per second. Okay, and that is given by rpm into r tire divided by 9.5. rpm into r tire divided by 9.55. Okay, so here you know that whenever we are about to calculate the power, this radius of tire will not be there. If you know the value of torque and if you know the value of speed, and that needs to be divided by 9.55. Okay, so this will give us the value of power in terms of watts. Okay, and whenever it gets divided by 1000, we will get the power in terms of kilowatts. Okay, so generally we will represent power in terms of kilowatts, not the watts. Okay, so this is about the power which is required to generate this much amount of torque, or whatever value of torque will be there, right? Now sometimes what happens, say for example, if I have to move the particular sedan or a four-wheeler car at a typical speed. Okay, so I want to get my maximum velocity of say 50 kilometer per hour in some 10 seconds or 20 seconds. So what I will require? I will require very high starting torque, right? But what happens generally? If you require very high starting torque, then the rating of motor should be very much high. Okay, but what happens when we require we get the motor with high rating? Of course its cost as well as weight, size and weight of that motor will be quite large, and we have to set this particular electrical motor within vehicle only, right? So every time it is not possible to use the motor with very high rating, right? Because it is costly also, it is bulky also, right? So what we will do, we to multiply the requirement of torque, to multiply the torque, we will introduce one mechanical device which is known as gears. Okay, so here comes the application of gears. So what generally gears do? Gears multiplies the torque. Okay, why? Because the electric vehicle, not electric vehicle, but electric vehicle motor may give less torque than desired or vehicle requires. Okay, and this is the reason why we are using a gear to multiply the torque. So gear is used to multiply torque by some factor, say n. Okay, so generally this vehicle torque will be equal to n times the actual motor torque, right? So what will happen to vehicle rpm? The vehicle rpm will be reduced by this factor n. So vehicle rpm is reduced by n. Okay, so what will be the new value of vehicle rpm? Vehicle rpm will be actual rpm of the motor divided by n. Okay, so in the previous sessions of electric vehicle, we have seen the use of these gears. Okay, we have seen the use of single gears also, as well as multiple gears also. Okay, and how these gears are used to get the desired speed torque characteristics in case of induction motors, or in case of DC motor, or whatever motor we will use, right? So whether we are dealing with the battery electric vehicle or hybrid electric vehicles, gear will play important role. But as we have seen, generally these electric vehicles uses a single fixed gear only. Okay, so these electrical motors are usually designed to work efficiently with this large range of speeds and torque that we know. Okay, and this is the reason why it normally uses a single fixed gear. Okay, and that would be the preference, as long as one can meet all vehicle requirements with the motor and a fixed gear. Okay, so we are going to change this gear ratio, right? But remember one thing, whenever we are going to change this gear ratio, what will happen to power, right? Generally power does not change with gear ratio. Okay, so it remains same, right? So we have introduced the gear also. Now we will be able to classify what are the vehicle performance parameters and how we will be able to find out these parameters, right? So if we talk about the performance parameters, then definitely the torque generated by the motor, this will be first parameter. Second parameter will be speed of the vehicle in kilometer per hour or in terms of revolutions per minute, and then power consumed by this motor, right? So all these parameters, torque, speed and power, these are determined by electric vehicle motor. These are the powers determined by electric vehicle motor. Okay, and what gear will do? Now gear can multiply this torque, but at the expense of speed. Okay, remember, whenever we use the gear, the vehicle torque you can see is multiplied by a factor n, which is nothing but the ratio, gear ratio. But what happens? Similarly, this vehicle RPMs are compromised. You can see the RPM will be reduced by a factor of n. Okay, so this is what happens. Okay, so we will be able to determine torque, speed, and power, which are to be determined by electric vehicle, but gear can multiply torque at the expense of speed of the vehicle. Okay, so this is what we require. Okay, this is when a steady state performance of the electric vehicle is going on, or vehicle is moving at a steady state speed. Okay, what about the maximum speed? Okay, there are two kinds of speed. One is, you can say, nominal values, and another one is maximum values or peak values. Okay, so this is also one of the performance parameters that you must know what are the nominal values and what are the peak values. Okay, so what are the nominal values? Definitely nominal values of this torque, speed, and power, right? As well as peak values of this torque, speed, and power. Okay, well, when we will get these peak values? Peak values are for a short time, say some 10 to 20 seconds. Okay, so whenever we are going up a grade, or we are starting from the rest, at that time we will require some high amount of torque, and whatever torque is produced by the motor at that time, that will be the maximum torque that can be generated. Okay, and this comes under the category of peak values, and this maximum torque, peak torque, will be required for some short time. Okay, say for 10 seconds to 20 seconds only. Okay, so we will be able to calculate these performance parameters of electric vehicle: torque, speed, and power. Okay, so now our questions will be justified that how much power is required to drive vehicle, how much energy is required to carry out a road trip, right? And to find out these two parameters, the power and energy of a vehicle, we should know the different physical parameters of the vehicle, right? So in order to find out these parameters, you must know what is the composite mass of the vehicle, which is also known as gross vehicle weight. Okay? Gross vehicle weight. Okay, what do you mean by gross vehicle weight? The weight of the vehicle, including the weight of passengers and the goods. Okay, then it also depends on the condition of the roads. Okay, so you must know what is the condition of the roads. Okay, it will generate the rolling resistance, right? Then you must know what is the aerodynamics of the vehicle. What is the aerodynamics of the vehicle? Okay, because this aerodynamics will give us some aerodynamic drag. Okay, so this is the amount of force that vehicle needs to overcome, aerodynamic drag force. And then you also need to know what is the incline that it needs to traverse. Okay, the incline that it needs to traverse. Okay, that will give us the gradient resistance. Okay, then you must know about the drive cycle. What do you mean by drive cycle? The values of velocity and acceleration at different points of time. Okay, so we must know what is velocities and accelerations at different points of time. Okay, then the peak values or maximum value. So what is the maximum speed and maximum acceleration of the vehicle? Maximum speed and maximum acceleration of the vehicle. Okay, so these are the WH questions. Okay, you must know these questions. What is the gross vehicle weight? What is the condition of the road? Aerodynamics of the vehicle? What is the incline that it needs to traverse? What are the values of velocity and accelerations and maximum values of speed as well as acceleration? Okay, so whatever tractive force is generated by this electric vehicle, what does this tractive force will overcome? This is our question, right? So the first questions we need to give answer is, what does the tractive force overcomes? Okay, so answer is already given to you. Okay, let us go back to one simple figure where we have one typical road. Okay, so there is one vehicle. Okay, this is the vehicle moving in upward direction. And this is my angle theta, right? So now there is a vehicle which is moving in upward direction, right? So what will happen? Whatever traction force is required to move this vehicle in upward direction, the tractive force which is generated has to overcome. First thing is aerodynamic drag. Okay, so generally this is the direction in which we will experience the aerodynamic drag, right? So this is my first point. We need to overcome aerodynamic drag. What is the second point? Second point, we will be able to overcome rolling resistance. Okay, now where is rolling resistance? Rolling resistance is in between the wheel of the, say suppose this is my wheel of the vehicle. Okay, so between the wheel and road surface. Okay, so here is what we are getting, rolling resistance. Okay, and then because of the weight of this particular vehicle, we will get some force mg downward in downward direction. Okay, and this force will have two components as we have seen. The first component is vertical to the vehicle, that is known as mg cos theta, and another will be in this particular direction, which is mg sin theta. Okay, so this mg sin theta is nothing but it is known as uphill resistance or gradient resistance. So we have this uphill resistance, and finally to accelerate the vehicle we will require some acceleration force. Okay, so these are the four forces which needs to be overcome by the tractive force of the electric vehicle. Okay, so what is the amount of this aerodynamic drag, what is the amount of this rolling resistance, what is the amount of this uphill resistance and acceleration force, that needs to be known to us, right? So coming back to aerodynamic drag, so we already have derived, seen the equation of aerodynamic drag. It is given by half rho CD A times V square. Okay, so this is how we will be able to calculate aerodynamic drag, where this V represents velocity of vehicle in meter per second. Okay, then rho is nothing but density of air. Okay, it is air density considered at standard temperature 27 degrees Celsius, and its value is fixed to 1.2 kg per meter cube. Okay, so this is the value of rho. Then we have CD, which is known as drag coefficient. Okay, so different values of this drag coefficient already we have seen when we have gone through the introductory chapters, lectures of the course, right? And then there is A. This A is nothing but the vehicle frontal area, or you can say projected area. Okay, this is my vehicle frontal area or projected area in meter square. Okay, so this is how we will be able to know the value of aerodynamic drag. Okay, and this is the amount of force which will act in opposition to the movement of the vehicle. Okay, so suppose I want to drive my vehicle, if I want to move my vehicle, then if my force is equal, generated force is equal to aerodynamic drag, then what will happen to vehicle is not going to move. Okay, I will have to generate more amount of force with respect to this aerodynamic drag, then we will be able to move that particular vehicle. Okay, so this is the first kind of force which is opposing the movement of vehicle. Then let us consider the second force which again opposes the movement of vehicle, and it is known as rolling resistance. Okay, and this rolling resistance is given by mg mu into cos theta. Okay, where this m is nothing but the permissible load, or you can say gross vehicle weight. The permissible load in kg. Okay, then what is mg? Mg is actual, you can say, weight. Okay, in newton or kg into meter per second square, where this g is gravitational force and it is equal to 9.81 meter per second square. Okay, then there is one more parameter which is mu. It is nothing but rolling coefficient. Okay, so for different road surfaces we will have different values of this rolling coefficients mu, right? And theta, of course we know theta is nothing but the grade. Okay, grade over here. Okay, so generally the value of theta is limited to 12 degrees only. Okay, So it is around 0, you can see. So cos 0 value, cos 0, if we consider the flat road, then cos 0 will be equal to 1. In that case, my rolling resistance would be equal to mg mu only. Okay. And if we consider theta equal to 12, which is generally the maximum value of grade, in that case, cos 12 will be equal to some 0.978. Okay, which is also around 1. Okay, approximately this is equal to 1 only. Okay, so in that case also this equation will reduce to mg mu. Okay, so generally the rolling resistance is approximately given by mg mu, not mg mu cos theta. Okay, so to find out this, we will have this equation mg times mu. Then there is one more resistance, or you can say climbing force, which is given by uphill resistance. Okay, so you also need to overcome this uphill resistance, or we can say gradient resistance, or you can say the climbing force, right? And this climbing force is given by mg times sine theta. Okay, so here theta value will be given in degrees. Okay, and we need to convert this degree into radians, and then only we have to find out the values of theta. Okay, so we need to find out the values in radians. So the maximum grade will be given by theta is equal to theta into pi by 180 radians. Okay, now suppose we have to find out this grain, or you can say inclination. Okay, so how we'll be able to find out this grade or inclination? Okay, for that you will require the length as well as height of the particular road. Say for example, this is my theta. Okay, and I want to find out this theta, right? So we have one vehicle or object which is moving in particular direction, right? So in this downward direction we will have our climbing force, which is equal to mg times sine theta, right? And in this direction we will have mg cos theta component. Okay, and parallel to this we will have this, right? Now suppose this is the length and this is the height, right? So we may consider one triangle here, over here you can see. Okay, and in order to find out this grade, now what we will require, suppose we are finding out grade in terms of percentage, then it is equal to the ratio of height of grade, to the base or length of grade multiplied by 100. Okay, so h by l into 100 will give us the grade in percentage. Okay, and suppose you want to find out the grade in degree, then it is given by tan inverse h by l. Okay, so this is the grade you will be able to find out, and the maximum value of grade normally is considered to be 12 degree. Okay, so it will have some value of mg sine theta, but when we talk about mg cos theta, that is cos theta, it is around generally equal to 1, and that is why this cos theta is neglected, and the rolling resistance is generally to be considered as mg times mu, where mu is my rolling coefficient, depend on the condition of the roads. Okay, whenever we have a smoother road, that mu will be less, and whenever we have a rough road, the mu will be more, right? And it will be given to us. Okay, so this tractive force which is created by the powertrain, what it will do, it will first overcome all these resistances: aerodynamic drag, rolling resistance, gradient resistance, etc., and then it will provide the acceleration. Okay, so this is our conclusion, a very large conclusion, that the tractive force created by powertrain first overcomes all these resistances and then it will provide acceleration or to the vehicle. Right. So now we will be able to calculate this force due to drag, force due to rolling resistance, force due to gradient for different vehicles, right? So let us try to find out this aerodynamic drag at certain velocities. Okay, aerodynamic drag, rolling resistance, and climbing force or gradient resistance for these different cases, right? So we will consider one simple example for this. Okay, so we have to compute forces due to drag, rolling resistance, and gradient for the vehicles given below, for the following vehicles. Okay, assume rho is equal to 1.2 kg per meter cube and theta is equal to say 8 degree. Okay, so we need to calculate the drag at two different velocities. Okay, so let us say we have been given some vehicles. Okay, then the gross vehicle weight in kg is also given to you, then drag coefficient CD, area in square meter, mu, velocity v1, velocity v2, both are in kilometer per hour are given to you, and the radius of tire in meter is given to you. Okay, so the first vehicle we are going to consider is a two-wheeler. Okay, then we have been given the parameters for three-wheeler as well as four-wheeler. Okay, so the gross vehicle weight of two-wheeler is say 200 kg, CD is equal to 0.9, area is 0.6, rolling resistance is 0.015, velocity 1 is 30 km per hour, velocity 2 is 80 km per hour, and radius of tire is 0.28 meter. For three-wheelers, these parameters are 600.45, area is 1.6, mu is same 0.015, vehicle velocity 3080, radius is 0.2, and for four-wheeler the gross vehicle weight should be 1500 kg. Drag coefficient is 0.3. Area is somewhat larger, 2.5 square meter. Mu is same. Velocity remains same, and tire radius is 0.3 meter. Okay, so these are the data given to us. Okay, what we need to find out? We need to find out the aerodynamic drag, rolling resistance, and climbing force at two different velocities, 30 km per hour and 80 km per hour, right? So let us try to calculate it for a two-wheeler. Okay, we will try to calculate it for two-wheeler, and for three-wheeler and four-wheeler will be your homework. Okay, you need to calculate these two parameters for two-wheeler vehicle and three-wheeler vehicle. Okay, so now we know the equation. Okay, equation of drag in Newton is known to us. It is half rho CD A V square. Okay, so this is what we are having. Okay, now consider the velocity 30 km per hour first. Okay, so at 30 km per hour, your drag should be half rho. What is rho? Rho is given to you 1.2 kg into kg per meter cube. Coefficient CD is 0.9. Upfront area is 0.6 square meter, and V square velocity is 30 km per hour. Now whenever the speed is given to you in kilometer per hour, we need to convert it into meter per second. Okay, so 30 into 1000 divided by 3600 whole square. Okay, so upon solving, you will get 22.5 Newton. Okay, so this is the aerodynamic drag which is generated by the vehicle. Okay, so now whatever motor force will be generated, tractive force should be greater than these values only. Okay, this is only the drag. Okay, now consider 80 km per hour speed. Okay, so at 80 km per hour, what should be the drag? Let us calculate. Half all other parameters will remain same, only V square is going to change, right? So 80 into 1000 divided by 3600 whole square, and it is equal to 160 Newton. Now see the difference. Whenever my velocity is 30 km per hour, at that time aerodynamic drag generated is 22.5 Newton only. But if we increase the speed to 80 km per hour, the aerodynamic drag offered by the vehicle is now 160 Newton. Okay, so more tractive force will be required to move the vehicle, and this is true because you know the equation. From the equation only we will be able to know that drag is proportional to square of the speed. So if we are going to increase the speed, definitely drag is going to increase. Okay, so this aerodynamic resistance keeps on increasing while with increase in the speed, right? Now let us talk about the second parameter, which is my rolling resistance. Okay, so we know that rolling resistance is given by mg mu cos theta. Okay, but as we know, this cos theta is approximately equal to 1, and this is the reason why we are neglecting this, and we will consider only this equation mg times mu. Now m is the gross vehicle weight. For two-wheeler it is given to you 200. Okay, and g is gravitational force 9.81. So 200 into 9.81 into mu is given to you 0.015, and that turns out to be 29.43 Newton, right? So this is the rolling resistance at velocity v1 30 kilometer per hour, right? Now if I increase the velocity from 30 to 80 kilometers, what will happen? Does this rolling resistance is going to change? No, because you can see the rolling resistance does not depends on the velocity of the vehicle. Okay, so it will remain constant to 29.43 43 newton, whatever may be the speed. Okay, so for both the velocities v1 and v2, the rolling resistance remains same, that is 29.43 newton. Okay, similarly, okay, so at 80 kilometer per hour also we will get the same value. Now consider climbing force. So climbing force equation is given by mg times sine theta. Okay, so m is 200, that we know, gravitational force is 99.81, and sine, now theta is given to you 8 degree right here. Okay, but remember, whenever we are calculating the climbing force or rolling resistance, this degree needs to be converted into radian, right? So sine 8 into pi by 180. Okay, and the answer we will get is 271.84 newton. Okay, this is the answer. Okay, at velocity v1, that is 30 kilometer per hour, and as this climbing force is also independent of the velocity, the speed, the force at 80 kilometer per hour should also remain same, that is 271.84 newton. Okay, so this is what we are getting, right? Now similarly, you will be able to find out the aerodynamic drag, rolling resistance, and climbing resistance for this three-wheeler and four-wheeler vehicle. Okay, so it is up to you to calculate these three parameters for these remaining two vehicles at v1 30 kilometer per hour and velocity to 80 kilometer per hour. Okay, so now we know one thing very well. What is the thing? Say, I have the aerodynamic drag at 30 kilometer per hour is fd equal to 22.5. Then I have rolling resistance frr equal to 29.43 newton, and we have climbing resistance or gradient resistance fg equal to 271.84 newton. Okay, so if I add this all, ft will be equal to fd plus frr plus fg, and it turns out to be some approximately 325 newton. Okay, so whenever we are going to generate the tractive force, then this tractive force must be greater than or equal to this value, then our vehicle will move in forward direction. Okay, if our motor is able to generate the force which is equal to 325 newton, then what we are doing, just we are nullifying the resistances offered by the vehicle. But in order to accelerate this vehicle, we need to apply more than this value. Okay, so whatever tractive force is there, this tractive force required will be larger than this 325 newton, because this much amount of force will be used to overcome the resistance which is offered by this electric vehicle. So we know the tractive force now. Okay, so the total tractive force to be generated is given by acceleration force, drag, rolling resistance force, and gradient force. Okay, so this is the equation which we are going to use in order to find out the total tractive force required for the vehicle to accelerate at certain speed. Okay, So now if you know the force required, then you must know what is the power which needs to be applied to vehicle to move. Okay, now we know the value of traction force. Okay, and to generate that much amount of force, we have to give the power to the motor. Okay, so what is the tractive power which is applied to the vehicle to move? That is also important, right? So the power, tractive power, P track, applied to vehicle to move. Okay, so vehicle needs traction power, okay, which is applied for it to move and accelerate. And this traction power in electric vehicles will come from where? Of course, battery. Okay, so it comes from battery through motors and its control circuitries. Okay? So the traction power creates a force F track on the vehicle to move forward is given by P track is equal to F track into velocity v. Okay, and the resulting torque T will be equal to F track into R wheel or R time. So these are two values, the power required and the torque required to accelerate the vehicle. Okay, so this torque and speed are the fundamental parameters of a motor, or in case of petrol engine, for engine. Okay, and vehicle RPM needs to be obtained from this equation. V is equal to, we already have seen this equation, RPM into 2 pi radius of wheel divided by 60. Okay, so this will give us the speed V in meter per second. Okay, and whenever speed is given to you in kilometer per second, then also we know. Okay, so whenever we have velocity in kilometer per hour, at that time we will get V into meter per second needs to be multiplied by 3600,000. Okay, so this is how the meter per second speed will be converted into kilometer per hour. Okay, or we have one more equation, 3.6 into 2 into pi by 60 into speed in revolutions per minute and r width. Okay, so ultimately it will give you 0.377 rpm into r width. Okay, this is my v in kilometer per hour. Okay, so the conversion from kilometer per hour to meter per second to kilometer per hour will be required in order to analyze the performance of electric vehicle as well as hybrid electric vehicle. So we know about the traction force, which is given by this equation: acceleration force plus aerodynamic drag plus rolling resistance plus climbing force. Okay, so in case of yeah, we don't know the equation of FA, right? So FA generally is given by m into a, right, where a is nothing but the acceleration and it is equal to dv by dt. Okay, so we may have my final velocity by initial velocity t2 minus t1. This is how we will be able to calculate the acceleration. Okay, then we also will be able to calculate the energy consumed by the vehicle in motion, and generally it is nothing but the integration of the traction power, right? So this is what required to identify, to find out the traction force as well as traction power, and also you will be able to calculate the torque. Okay, so we will stop here. In the next lecture we will solve some example based on this finding out the total traction force as well as traction power and the torque of the vehicle. Okay. And we will also see the concept of regenerative energy. Whenever braking is applied at that time, how this energy will be useful. Brake energy, kinetic energy of the vehicle will be used to charge the electric battery. Okay, so we'll stop here. If you have any questions, then you may ask.